Here in section 14, we're going to begin to break down this weight or measure calculation for less than container load ocean imports, determining if our cargo as an importer is dense cargo or voluminous cargo, and how we're going to be charged based on the characteristics of our freight. We'll start off with some basic stuff here. All ships and ocean containers have both weight and space restrictions, meaning the ships themselves and the weight and space restrictions on the actual ocean containers too. Second bullet, this whole concept of weight or measure is based on the need for the carrier to optimize the return on its assets, meaning make the best use of space on the ship and in the containers. We'll wrap up this slide by saying that in any given container, carriers can handle cargo with different characteristics. For example, small cartons or crates that are very heavy, aka also known as dense cargo. Or, in the same container, they could have larger parcels, cartons, that take up a lot of space but that don't weigh very much, aka fluff cargo or voluminous cargo. And we will point out before we move on that the digital image on the right and this ship starting to capsize, goodness forbid, is because of the distribution of weight on the ship, the distribution of containers, and the weight of the cargo within those containers. We've been talking about weight or measure from a financial perspective, but there's a safety aspect to this whole story as well, and it's important to point out. Let's take our weight or measure conversation a little bit further and provide an illustration, first using ping pong balls and then ball bearings. What happens if an NVOCC accepts a large LCL shipment of ping pong balls from a shipper that nearly fills a groupage container? It takes up 3/4 of a 40-foot container that was intended for consolidated cargo. As you can imagine, because ping pong balls are super light and take up a lot of space, first sub-bullet point, the space capacity of the container will be taken up long before it reaches its weight capacity. It's just going to fill up with maybe 1,000 kilos, if lucky, of ping pong balls, but all the space will be gone before the container hits its weight capacity. That translates into the underutilization of the asset, the container itself, and losing revenue. Think of it this way, second sub-bullet point. If the consolidator charges the shipper on the actual weight of the ping pong ball, let's say it was 1,000 kilos, the equivalent of 1 cubic meter, it will be impossible for them, the consolidator, to make a profit. As such, the consolidator must calculate the per CBM charge on the amount of space the shipment takes up, not its actual weight. That's a super important concept. In our next section, we're going to do the math behind that. Let's go to the other extreme, an illustration using ball bearings. What happens if an NVOCC accepts a large LCL shipment of ball bearings from a shipper? Let's say 10 tons, 20 tons. Let's go a little bit higher, 20 tons of ball bearings, or the equivalent of 20 cubic meters. Because ball bearings are dense and heavy, the weight capacity of the container will be taken up long before it reaches its space capacity. It's the exact opposite of what we were just talking about with the ping pong balls. Ping pong balls, space capacity is consumed long before the container hits its weight capacity. Ball bearings, the weight capacity is consumed long before the container hits its space capacity. As such, second sub-bullet point, the consolidator will charge the per CBM rate on the actual weight of the shipment. But due to weight restrictions, a great deal of space will remain in the container, which translates into an underutilization of the asset and missing out on revenue opportunities. Again, dense versus voluminous cargo is all about restrictions by weight and space. The carrier, the consolidator, the NVOCC is always going to figure out which calculation, weight or measure, is more profitable for them. Let's take a look at both ping pong balls and ball bearings and try to answer the question, what does an NVO prefer, shipments of ping pong balls or ball bearings? The answer might surprise you. Ideally, NVOCCs, also known as consolidators, that offer LCL services seek a combination of dense and voluminous cargo for every container. So it isn't one or the other, they want both. And the reason why is quite easy to understand. For example, A base load, as it is called, of ball bearings helps to maximize the weight capacity of a container, while cartons of ping pong balls can take up additional space without adding too much weight to the container. When combined, the dense and voluminous cargo optimizes the revenue potential of the container, thus making the best use of the asset. When a consolidator is loading a groupage box, they're going to put the ball bearings on the bottom and spread them out to spread the weight across, so the integrity of the container is not compromised, and when the container is loaded on the ship, it's not lopsided either. That safety component we spoke of a second ago. But before that container is closed out, the consolidator is going to put the ping pong balls on top of the ball bearings. They don't weigh very much. They'll take up space, and the charge is going to be based on the volume of the ping pong balls. That is how the carriers optimize their revenue. Second paragraph. In order for consolidators to take full advantage of a container's capacity, they must be able to plan the weight or measure of each container with as much advance notice as possible. This need requires that NVOs work closely with shippers and/or BCOs to book cargo and quickly ascertain details of its characteristics. Consolidators always want to know the same thing. How many pieces? What do they weigh? What are the dims of the cartons? And what's the description of the goods? Ping pong balls or ball bearings? That way, they can not only plan how much to charge a customer, but also how to plan the loading of containers. In the end, it is not only the responsibility of the 3PL to execute upon its service portfolio, the 3PL being the consolidator, the BCO has to understand how the 3PL business model works. That means being familiar with the operational aspects of the forwarder's services, but also how they make money and incur expenses. In that way, the BCO can better enhance their own value proposition by understanding the inner workings of all supply chain partners. This is important. In global trade, it's not enough to understand one's own business. One has to understand the business of all of their partners, too. And to understand how consolidators, freight forwarders, 3PLs, these synonymous terms, how they work, incur expenses, and make money, that is advantageous to the BCO. You can't just understand your own business. You have to understand your partner's businesses, too. To summarize, in order to maximize space and revenue potential, LCL freight is subject to charges based on the actual or volume weight of a given shipment. We've said that throughout the entire section. Basically, as we see in parentheses, how much it weighs or how much space it occupies. That calculation that makes that determination is based on simple math. We'll see it in the next section. But as a trade tip for now, we'll say that all carriers, 3PLs and or NVOs that offer this type of service, they will each use weight or measure on LCL shipments. That is unequivocal. We'll set up the math in the next section with this last slide here. For ocean LCL shipments, the point of equilibrium where weight equals measure is 1,000 kilos equals 1 cubic meter, also known as a CBM. The key to a weight or measure comparison is being able to convert the actual weight in kilos to cubic meters or express the actual weight in cubic meters. 1,000 kilos equals 1 cubic meter. With the same standard of measure, this cubic meter, it is possible to determine which is greater, weight or measure. And we said this a couple of times, but we like to be thorough here at Mercado. So we'll say as a trade tip, 1,000 kilos equals 1 metric ton equals 1 CBM. And just to give you an idea of the excitement coming up in the next section, this is where we will see steps for calculating weight versus measure, starting with the standard system, and then we'll do it with the metric system. See you then.